Hello everyone and welcome back to Leetcode. Today we are doing the number of islands problem. So this says we're given an m by n 2D binary grid, creatively called grid, which represents a map of ones for land and zeros for water. We need to find out how many islands are in this map. We may assume the map is completely surrounded by water, so there's sort of a ring of zeros. So in this case here, there's no chance of the land sweeping around, and we've actually got a little bay here. These are definitely two different islands. Now, this is immediately my brain says flood fill. What I want to do is I want to find a one, say the first one, and then just go as far as I can in all directions and collect up all of those points and say that's an island. And then I want to search if there's any left. Same here, I want to grab this one, say all of those form an island, and then see if there's any ones left. There is. I want to grab this one, grab all the adjacent ones. There aren't any, so that's an island. And then finally this one here, do the same, that's an island. I think this will be it's the obvious way forward, and I'm fairly sure it will be the correct way forward. Let's just check our constraints here. M and N are both under 300, so it's not a very big grid. So I think this will be absolutely fine. So I think the first thing I want to do is turn this grid into a set of coordinates. So this one is going to turn into a 0, 0, and these zeros are going to get dropped completely. And then while there's anything in locations, we're going to need a few different things here. What I want to do is how do I want to do this? Maybe I'm going to turn this into an adjacency list or adjacency dictionary. Each coordinate mentions which coordinates it's adjacent to. And the locations is the set of adjacency.keys. So while there are locations still to visit, what I want to do is just trying to think the best way to do this. What I want to do is, so while there are any locations left, what I want to do is pick a seed is logs 0, logs.remove seed. I think I can do that. I just need to get some element out of the set. In fact, I think I can actually do this even easier with logs.pop. And then I need to do effectively a breadth first search. Q is, let's just create a queue here. Import collections.deck, and it's going to start with the seed while the queue has anything in it. And islands plus equals 1. Next equal cur is q pop left. If cur in logs dot remove. Now let's just turn this back into a 0. Maybe I don't want to remove it from the set yet. So my thinking up here was initially I was just going to remove the seed and say it's done. But what I actually want to do is I just want to pick it and say, right, I'm going to start my search from there. For neighbor in the adjacency of current, if neighbor in no, yeah. No. Let's just go q.append neighbor. I think this is basically it. So the flow here is, well, we'll turn this into a set of land locations where each one mentions what its neighbors are. We have initially no islands. While there are some locations that still have land that we haven't seen, what we're going to do is we're going to pick one randomly. We're going to say I've found an island, or I found another island, and then what I want to do is I want to go through and find everything that makes up that island. So I put the seed in the queue, and then I start taking things off the queue. So if it was here, I start here, and then if I haven't seen it before, if it's still in my set of locations that I need to deal with, then I want to remove it from that set and add both of its neighbors into the queue. So this is going to turn into a 0 effectively, and these are now going to be in my queue. I'm going to pick one of them, say this one, and I'm going to remove it from, I'm going to turn it into water, basically. I'm going to go here, and I'm going to add both of its neighbors, which is here and here. Now this one here, when it comes off the queue, this isn't going to be dealt with because it's been turned into water effectively. We're double checking, is this still land? No, it's not still land. So we're not going to bother. We're basically digging our islands into the water to work out how many islands there were. And we're going to do that until we've consumed the entire island. That's this loop here. And then once we've done that, we're going to go back around and say, well, are there any locations left with bits of land? In this case, there aren't. So we are done. Islands is 1. Now, we have to do this parse. So what we need to do here is basically yeah. The adjacency is an empty dictionary for I in range. In fact, yeah, it's called for row in range len grid, for col in range len grid 0. What I want to do is if row col, no, what am I doing? Grid row col is equal to a 1. Adjacency of row col gets turned into a set. And then what I want to do is I want to look around me. So if row, no, if row is greater than 1, and grid, no. So I'm just dealing with the boundary case here. What I want to do is effectively work out what my neighbors are. So if row equals 0, I don't want to look at the -1 stuff. In fact, if row does not equal 0, what I want to do is check grid row minus 1 col. So if col does not equal 0, column minus 1. So basically the 4 places I need to check are, let me simplify this first. So up is equal to grid row minus 1 column minus 1. No, so column. Up 1 row, same column. Oops. Down is grid row plus 1 column. Left is grid row column minus 1, and right is grid row column plus 1. And then what I want to do is basically go through each of these. If up equals 1, edge row col dot add row minus 1 column. And then I want to do this for each of them. If down, I want to do it for that. Left, right, col minus 1, col plus 1. But I need to make sure here that I do each of these checks. If grid, if row equals 0, up equals 0, else up equals grid row. Then down here we want to do the same thing. So this is our ring of zeros effectively. If I'm here and looking up, then there's water. If row is equal to len grid minus 1, I'm already at the bottom. Down is equal to 0, else down as that. If col is equal to 0, if I'm already as far left as I can go, that needs to come back 1. I want to say left is equal to 0. Then final check, if col is equal to len row grid 0 minus 1 right equals 0, else right equals that. So this is all a bit gross. Yeah, it is what it is. Let's see if that works. There's probably a silly mistake in there somewhere. Yeah. Oh god, how do I do this in Python? Is there a peak? It has an attribute peak. 1 second. Quick Googling. Okay. That should get me one random element of the locations. Yes, I did, because for some reason this class does not start with a capital letter. I ran it too quickly. Let's make sure we use all the example test cases. Looks like it worked. We got 1 and then we got 3. The question is this fast enough? I don't love this, but it is just a one-off setup cost. There's probably better ways to do it. Anyway. Submit, let's see what happens. If we're too slow, we'll fix it. We were not too slow. We were quite slow, but we were not too slow, and that's what matters. Excellent. Thank you very much for watching. If you're in the UK, hope you're having a wonderful bank holiday, and for everyone else in the world, I hope you're having a wonderful day anyway. Remember to like, subscribe, comment, all of that good stuff, and I will see you next time. Bye.